Alright, this is going to be a demo of some features of Dune that we've been working on for the last 6 months or so relating to managing your project's dependencies. So that's going to be downloading them and building them before building your project itself. I just got a Docker container here that has just a bare Ubuntu image with opam installed. Let's just check out a camel version. Okay, so for the demo, I'm going to be building the package bonsai along with all of its dependencies. But bonsai needs a later version of a camel, and Dune currently can't build the compiler packages. So before we start, we're going to just quickly install camel 4.14.2. Have I done wrong? Yes, we dot there. And the reason that Dune can't do this itself is because the compiler packages can't be built in the Dune sandbox. Dune builds all of its packages in a sandbox environment, and the compiler currently can't be built in one location and then moved to another location, which means that it's incompatible with the way that Dune builds packages. There's a couple of other packages that have this problem too that we're going to have to work around during this demo, but we've got plans to change all that eventually and make it all handled by Dune. Okay, so now the compiler is built, we can start building bonsai. So first, let's just clone it. And rather than building this tip, we're going to check out one of the release branches. So we're going to check out the most recent one, the 0.16. Okay. Now, we can't use the release version of Dune to do this. We're going to have to build it from source. We can do that by installing it from its Git repo. I'm pretty sure that why didn't that work? Maybe we have to pin it. Pin Dune, like that? Okay, that seems to be working. So yeah, I'm pretty sure. Do we have to say that it's a Git repo? Okay, that looks more promising. So yeah, I'm pretty sure that the current tip of Dune has all the features we need in order to do package management. So this is going to download Dune from GitHub and build it, and then install it as if it was an opam package. Okay. Great. So there's our Dune. Yep, that looks good. So now we have to make a small change to this package before it will build as well. So there's, as I mentioned earlier, there's a couple of packages that we have to work around because they can't be built with Dune. And the way we're going to do that is create this Dune workspace file. This is a Dune config file that we can use to override some of the package sources to modify versions of those packages that we've changed to work with Dune. So Dune 3.14. And so those two packages are, just going to copy code from another window. So OCaml will find and OCaml build. So these are both low-level packages that a lot of other packages depend on transitively, and for various reasons they don't currently build with Dune, but we're going to fix this. The other thing we have to add to this file is a way to make it so that Dune can use the already installed compiler package rather than the one from rather than trying to install it as a new package, if that makes sense. So we need to say the OCaml system package has to be chosen, which is kind of a meta package that is just telling OCaml to use the system compiler instead of trying to install a compiler. We also have to tell Dune about those two pins. So we pinned OCaml find, and we've pinned OCaml build. Alright, and with that, we should now be able to solve the dependencies and then build a project. Let's try it. So Dune package work is the command to solve the dependencies, so to pick which versions of each package are going to be installed. This is going to take a little bit longer than it normally would because this is the first time that we run this command on this Docker image, which means that it has to download the entire OPAM repository first before it can use that metadata to solve the package dependencies of this project. Cool. So that had the effect of creating this Dune.lock directory. We can take a look inside. So it has all of these package files. Let's just take a look inside one of those. Let's see, maybe base, is base there? Base, yeah, so here's the lock file for the base package. So it's really just a transcription of the OPAM file, or some parts of the OPAM file for the package. So we can see its dependencies and its build command, and where to download the source for that package. And if you look at one of the modified ones, like OCaml find, we will see that the source has been changed to be the hacked modified version of the package that is compatible with Dune. So now that we've solved the dependencies, we should be able to build the project by running Dune build. Oh, that's failed. That's failed because there's some native dependencies that are missing. So we have to apt-get install some stuff before this will work. Dune, unlike OPAM, Dune doesn't install system dependencies for you, so you have to do that manually. I happen to know the Ubuntu names for all of these missing packages, so I'm just going to paste another piece of code. So this is just apt-get installing a couple of packages that are needed by the OCaml packages that bonsai depends on. So now those are all installed, we should be able to run Dune build. Oh, what was that error? Oh, I guess we also need col. Okay, that I missed that dependency. If I'm sorry. Apt get install -y col. Try that again. I'm not sure if col was a dependency of a package or if Dune was just trying to run the col program, but we didn't have col installed. Because it might be the case that Dune uses col to download the package sources before it builds them. And this is currently lying to us. It's not 95% of the way done. It just hasn't figured out all the jobs that it has to do yet. So there's going to be, I think, like 1,000 or so. And this is going to take another 5 minutes or so. Also, currently we see the output of every command that is run during the build. So this is the output of all of the commands of all of the packages, all the build commands of all the packages that bonsai depends on transitively, which is something that's what we're going to fix. Because right now, if something goes wrong, it's a little bit hard to tell what went wrong. And there's a lot of noise that is unnecessary. Right. So now that bonsai is built, what can we do with it? So let's use Dune to make just one of the example programs or example web pages and prove that this has worked. So we're gonna build examples, hello world, and can we just build that whole directory? Let's see if this works. Great. And if we hadn't run that initial Dune build, we could have just run this instead, and the result would have been the same. So what that has done is it's created a folder in the build directory, build default examples. Oh, maybe I'm wrong. Examples hello world. Yeah, it's not there. How strange. Okay, maybe we have to build a specific file. So it'll probably be something like main.bc.js. Is that right? Okay, so now do we have a file that builds default examples? Hello? Cool, so that's had the effect of copying all of those files. We need that index.html file there too, though. How do we get that there? Do we just build it? Because there's index.html. So maybe this has the effect of copying it? Let's see. Cool, so there it is. So now we're going to go into this directory and run just any static web server. And now we jump into our web browser. There it is. So this was generated using JavaScript that was compiled from camel by Dune using bonsai. Well, the UI was made with the bonsai library, whose dependencies were all downloaded and built using Dune's upcoming package management features. All right, that's all for now.